Okay, here's home plate. Here's first base. It's 90 feet from home plate. These are right angles. Even though this is a diamond shape, it's really a square. Here's second base. Here's third base. And the runner is heading from home plate towards first base at a rate of 27 feet per second. And I'm going to call this little distance right here, how far he's traveled, K. So what we're told is that dk dt, that's actually increasing at 27 feet per second. And the distance, oh, by the way, if this is 90 feet, and this is 90 feet, this is 90 radical 2. That's the distance from home plate to second base. But as this runner is moving this way, the distance from the runner to second base is decreasing. It's getting smaller. As a matter of fact, if I share my screen, go to Desmos, there's the runner right there at home plate. And as K starts increasing, the distance from him to second base is decreasing. Okay, and we want to know how fast it's decreasing when he's halfway to first base, which would be 45 feet. Okay, so we need a relationship between all these variables. And so if we call S the distance from the runner to second base, what's true is that S squared by the Pythagorean theorem equals this 90 squared plus this distance right here, which is 90 minus K, the quantity squared. And if we take the derivative of all these variables with respect to time, we want to solve for ds dt. That's what we want to find. Okay, so we'll use implicit differentiation. The derivative of s squared with respect to t is 2s ds dt. And over on the right, the derivative of 90 squared is 0. The derivative of this term, using the power rule, bring the 2 down front. 90 minus k, reduce the exponent by 1, and then multiply by the derivative of the inside. That's the chain rule. Well, that'll be a negative 1 times dk dt. And to solve for this s right here, to solve for ds dt, we have to divide both sides by 2s. So I'll take a copy of that equation that we have so far. Go to board 2. I'll try to go to board 2. There we go. And so ds dt equals, well, if I divide by 2, these 2's will cancel out. If I distribute this negative 1, I'll get k minus 90. And I have to divide by that s. And I've got dk dt out here. Okay. And we want to know what's the value of this thing, the distance, the rate of change of the distance between the runner and second base at the time when k equals 45, half the way to first base. Okay, so when k equals 45, we got a negative 45 in the numerator. We've got this 27 feet per second squared as 27 feet per second as dk dt. The question is, what is s when k is 45? Well, here's the situation. This is 45. This is still 90. It was a constant. This is S. So S equals the square root of 45 squared plus 90 squared. Pythagorean theorem. Okay, so that's what goes here. Square root of 45 squared plus 90 squared. You do a similar thing for the distance from the runner to third base, but I'll let you work on that. And this should be a negative number because that distance from the runner to second base is decreasing. Okay, there you go. Hope that helped. If you have any questions, post a comment.